Now we'll start. So welcome friends once again to aiClub in the session 2 of today's lecture, and this is of course last session, last theory session of our deep learning class. So we'll discuss something about hyperparameter tuning and parameters and hyperparameters of neural network as applicable in RNN, CNN, and ANN. All everywhere, concept is same. So before we start the class, I want one of you to tell me a couple of which are main parameters and which are main hyperparameters of any neural network based on your understanding. Anyone? I want to take a shot at it.
Yeah, learning rate.
No, first tell me the parameters, which are the parameters, and then tell me which are the hyperparameters.
For a deep learning model, parameters
weights
and biases.
Okay, so you are telling they are parameters. Okay. What about
They are
what about hyperparameters?
hyperparameters is the learning rate, number of layers, number of neurons, and optimizers that we use, activation functions, everything that we can customize in a model while designing our model. All those are hyperparameters.
No, don't go by that hyperparameter tuning example that we learnt in that actually. Okay, so we'll see going forward. So I think you guys have a fair idea now. So I'm just reminding, it's a trivial actually. At this stage, it is trivial to see this kind of diagram. So assume this is our neural network, standard neural network. Input layer, hidden layers, and output layer. You are already like what kind of problem is this? Classification or regression? Neural network can do what? Classification or regression? Anyone? Any guess?
Neural networks can do both of these things.
Yeah, it can do both classification and regression. So two class classification it can do 0 and 1, and it can single node which it can do regression also. So it depends on how we train it, what kind of training data we train it. It can do both classification, two class classification, as well as regression. Yeah, correct. Thanks, Kavan. So now this is again like hyperparameters, as you correctly said, Soman. Number of neurons, activation function, and optimizer. Even optimizer that we studied, Adam optimizer or RMS prop or ADA grade, whatever optimizers we studied in one of the last previous classes, that also is a hyperparameter. Learning rate, batch size, and epoch. See, parameters and hyperparameters for any machine learning for that matter, any machine learning or deep learning parameter, the difference is hyperparameters will always be a part of model. They will define the model. Parameters will always be a part of model. So when you will complete your training, when you say that I have model equation, so model equation will have parameters. Whatever is there inside that model equation, they are parameters. Now there are some handles to achieve those parameters better, to achieve results better. We use some handles which are supplied from outside. They are supplied from outside, but when model is completed, we don't need them. They are supplied from outside. We use them to adjust our parameters and then we throw them away. We don't need it. Right? So such things are called hyperparameters. So hyperparameters are external to the model and the parameters are internal to the model. So learning rate. So learning rate you define at the time of training. But when your model is complete, nobody is asking you what learning rate you use, right? Because that is immaterial. You got your model, it is having some weights and biases, number of neurons, number of layers you are having, and it is giving good results. So nobody is asking you what learning rate you use, right? To train the model. It is immaterial. It is external to the model. So that is the broad definition I am giving you. Now, training number of layers is something which is the part of your model. So there are two, like if you have more number of layers, you will have overfitting, and if you have less number of layers than required, you will have underfitting. I think you have some feeling of that. More number of layers, your model becomes complex, so you are heading towards overfitting. And if you are going less number of layers than required, you are going towards underfitting. Okay, so number of layers are important. We know that. And batch normalization, I think you guys are already aware. So batch normalization is a layer which we give after every output. Before giving input to a next layer, we always use batch normalization. It gives a faster convergence to neural network, plus it avoids overfitting. It helps in avoiding overfitting. Then something called dropout that we learned in our regularization lecture. So dropout also we use at a hyperparameter. So we can use 20% dropout, 50% dropout, 70%, 60%. So that also is supplied from outside. So that also is one of the hyperparameters. So let us go a little bit more in detail. So I think this is a neural network. We are right now in this slide, we are talking only about parameters. So parameters are your weights and biases. Weights and biases. So this is one of the representation of neural network. Like X stands for your input, Y stands for your output, P is the probability vector. Means suppose your output layer is having 3 neurons, 3 classes. So P will be the probability vector, which will tell you which is the highest probability, and from there you will pick your class. So that is the probability vector. H is nothing but your hidden function. Then I think you should be able to interpret the superscript and subscript and superscript. W superscript 1 means weights of first layer, and then subscript of you are using W21. W21 means weights between neuron 2 and neuron 1. W21 means weights between neuron 2 and neuron 1. And on that, if W21 is subscript, and suppose if superscript is 1, that means it belongs to layer number 1. So these are the basic nomenclature which we use when we got introduced to neural networks. I'm just revising it. So you see here in between we have a matrix here, like W1 is on the top, 1 is the superscript, and in that after that we have subscript like W11, W12, W13, W21, W22, W23. So Dr. Shailesh, you understand all this superscript and subscript now?
Yeah. Yes.
So that 1 means it is representing one layer number 1. W11 means weights between 1 and 1. So like 1 and 1 means first layer first neuron of first layer and first neuron of second layer. Like that we are connecting. So W21 means second neuron of first layer is connecting to first neuron of second layer, right? So these are the basic nomenclature, and then we, of course, with that multiplication, we do that vector multiplication, we get a hidden function, and for that getting this hidden function, that is H is hidden output of the hidden layer. So once we do this WX into W, when we do then we apply some kind of activation function on it. So it is just I'm giving you just kind of revision of very basic things that we studied when we were introduced to neural networks. So now let us go a little bit more into what are hyperparameters and what are hyperparameters and what are hyperparameters and what are parameters. So weights and biases are parameters for us. Of course, weights and biases are parameters. So now parameters are weights and biases. Hyperparameter is learning rate, number of iterations. Number of iteration means epochs. The number of hidden layers, that is also hyperparameter. Number of hidden layer units. Unit means number of neurons in the hidden layer n, and the choice of activation function. These are all hyperparameters. I'll repeat hyperparameters: learning rate, number of epochs, number of hidden layers, number of neurons in hidden layers, and the choice of activation functions. These are hyperparameters. And then okay, so these are and parameters are weights and biases. Okay, so this is one understanding. Now, again, same thing repeated here. Same thing repeated here. This. So nothing much to discuss here. So now let us go into effect of hyperparameter. What is the effect? Like each hyperparameter, suppose we change. It is a handle, right? To get a good model. So suppose we change a hyperparameter, what is the effect? So suppose you are churning, you are playing with learning rate. So its sensitivity is rated as high. Means effect is large on the final model. Sensitivity is rated high means the effect is having its effect is high on the final model will get, and learning rate also decide how much training rate will be, training time will be there. So learning rate is very sensitive. Sensitivity is very high means it has very high effect on your final model, your training time. Optimizer type. Optimizer, whether you choose Adam, you choose Adagrade, you choose RMS prop, whatever you choose. So they change your model, but sensitivity is low. Then some parameters have optimizer also have parameters. So there is a beta 1 parameter in Adam. So even if you change it, the sensitivity is low. Batch size. Batch size is also a hyperparameter. So we know that mini batch gradient descent, we have learned mini batch gradient descent, right? So we do one weight update for one batch. Suppose batch is of 50-50. So we average out gradients for 50 records, and once we do the updation for once for 50 records, we'll do the weight updation. And this is the most common scheme for our neural network training. So mini batch size, suppose if you change, then you have, it has kind of low kind of sensitivity. Weight initialization, like before starting the neural network, you randomly initialize weights, right? You randomly initialize weight. So weight initialization also has an effect on your final model. So its approximate sensitivity is medium. Loss function which you are using. So loss function has a very high sensitivity. Model depth means number of layers which you are using. That is also a hyperparameter. It has medium kind of sensitivity. Layer size means how many neurons you are having in one layer. So that is also having very high sensitivity. And layer parameters like kernel size and your CNN, you have kernel size, right? And then you have activation functions and all that. So that has medium. Then weight of regularization. Regularization we use L1, L2. So that has medium kind of sensitivity, and non-linearity, it is having low kind of. So I am not sure what is meant by non-linearity here, but rest I have explained you everything. So non-linearity I am not sure as of now, but something if they are using non-linearity as a hyperparameter, that is having some kind of low sensitivity. So which are your high ones? High ones are the layer size. Layer size, number of layer 1, 2, 3, 5. That is very sensitive, high sensitivity to the final model. Then learning rate is very important because it is also having high. Then after that you have medium ones. Weight initialization, generally people don't care for weight initialization. Some random distribution, they take it and they initialize the weights. So generally people don't care about weight initialization. So let us ignore it. Like I have not seen anybody changing weight initialization to get final model. Once you do it with some random initialization, you're okay. Generally it is not touched. Then maximum depth. Then you have layer parameters. These things are medium ones, but the most important are like learning rate and layer size, like how much learning rate you use, like how you decay it or what scheme you use to decay it, and then what kind of how many layers like you have, like a number of neurons in each layer. So these are the approximate rules of thumb. So you should be very careful for while working with learning rate. You should be very thorough with learning rate, like this kind of layer, learning rate if I'm using. What kind of model can I get? You should have some experience also working with learning rate, nice experience. Number of neurons in layers, that is also a very high sensitivity kind of hyperparameter. And how to use these hyperparameters, I think you have already done a hands-on in the beginning itself when you used when you did a CNN with the help of automatic hyperparameter process, which is random search you use, right? So these all the things to be varied there only. So you know hands-on how to do it. But I think you should be thorough with learning rate and number of neurons. So number of neurons everybody knows. So you should be very thorough and experienced with how to use learning rate. It is one of the very most sensitive parameters in hyperparameter in training of neural networks. So now hyperparameters and value considered, like when you start, which kind of values you should consider. So scaling of predefined features. So standard deviation, 10h and square root. Then number of hidden layers, number of hidden units, like neurons, hidden layer neurons. So generally multiples of 2, 1024, 2048, 4096. But these are just rule of thumb because 1024 also is a high number. You may want to start with a lower number of neurons. Number of layers, of course, 1, 2, 3, 4. A few increase beyond 4, your time will, neural net training time will increase hugely. Then back propagation learning rate, 0.01 is a standard thing which people start with. 0.05, 0.1 also people take it. And then dropout rate people generally start with 0.2 and go up to 0.5, 0.5 or 0.6. Then weight decay, L2 weight decay. L2 weight decay is a parameter in L2 type of regularization, which is L2 is nothing but Ritz regularization, which is done in L2 means you know the square of weights. So in that weight decay is a parameter. So you use the typically take 0, 10 to the power minus 6, 10 to the power minus 5, 10 to the power minus 4. These kind of values you take generally in that. And then I think I'm done with the. I just wanted to sensitize you today with parameters and hyperparameters. That's all. I wanted to make it sure that you understand the difference between parameter and hyperparameter and what are the important hyperparameters of deep learning. So it is learning rate, number of epoch, number of layers, number of neurons in layers, and the choice of activation function. So these are the main hyperparameters, and you know now how to vary it in hands-on. Okay, so I think I am done with it now. My class is over, and with this, all the theory classes of deep learning, our deep learning course this time are over. Okay. So I would open for a question for a couple of minutes as usual, and if you have any questions, you can ask.
I think it is. We have done some hands-on earlier only.
Yeah, earlier we have done hands-on, right?
So no question for where.
Yutika madam, any question?
No, sir, no question.
You should be clear what is parameter, what is hyperparameter. And in which is sensitive, which is less sensitive. So anyway, I'll share this slide with you today or tomorrow morning. I will share this slide with you, so you will have this all with you. And these values are only indicative what to be considered. They are very indicative, but you should, as you get more experience with hyperparameter tuning, you will arrive at your own values also. So if somebody has recommended it, so I thought showing something is better than nothing. So L2 weight decay, suppose you are putting 10 to the power minus 2 or 10 to the power minus 1, don't use it. Use it 10 to the power minus 4, 10 to the power minus 6, 10 to the power minus 5, those kind of things. Some idea you can take it from here. How to see, here he has used 16 neurons, he has used 1024 neurons, but there is a lot in between. Between 16 and 204, you might want to use 32, 64, that also you might want to use. And then activation functions, you are already aware, like we are using only ReLU for the hidden layer. Why you are using ReLU? To avoid vanishing and exploding gradient problem. So ReLU is standard for hidden layer activation function. Input layer, there is no activation. Output layer activation also standard based on your problem. Suppose it is a 2-class classification, you use sigmoid. Suppose it is a multi-class classification, you use what is that called, softmax. So they are also fixed. So only hidden layer is a variable, but that also is fixed, right? That also you use only ReLU. So all the activation functions in all the layers are already fixed. So you need not bother varying them. So only what you need to concentrate on is learning rate, number of layers, what kind of regularization to use, and how many neurons in each layer. These are the main hyperparameters which you need to concentrate. And maybe then you can try which loss function to use and which optimizer to use. That is also, but we see the effect is low, sensitivity is low. So top thing to vary is your learning rate and layer size. Layer size means number of neurons in the layer. These are the top two things to be varied as hyperparameter: learning rate and layer size. And maybe you want to vary number of layers also. That also is a determining parameters of neural network architecture. So these 2-3 things are there to vary. So as you gain some more experience, I think you will get better and better at it. So you have to solve more problems and gain more experience. There is no other way to it. So with this I close, and thank you very much for staying with me today.